Greetings. For those that don't know me, my name is Julian McQuade, and my group chose ocean pollution for our topic of choice as we are an island nation with a relevant border problem. Our infographic focused on hydrocarbons, different spills, deep-sea mining, negative health effects, and the cost per tonne of plastic to clean up, with our target audience being high school aged. As my focus on this project was mainly focused on human impact and the consequences, we'll dive a little deeper into those points today. But first, an arousal to gather interest in the coming topics. For those that don't know what this picture is about, it contains an image of a much-loved food called chili mussels. Have you ever had these? This animal is usually farmed near tidal flows, and as such, this animal is known as a filter feeder, as it cannot hunt for its food supply and remains subject to the tidal flow passing back and forth to feed. What many people do not know, however, is that you can contract diseases from eating these creatures, with HEV, also known as hepatitis E, present in almost a quarter of the mollusks tested. Due to poor waste management systems, combined with the before-mentioned tidal flows, allowing repeated feeding on waste products. This has resulted in more humans contracting the disease in European countries. This may affect your choice of meals in the future. With the arousal out of the way, the next point outlines what we are covering for today. During this talk, we will cover toxins introduced into the ocean, deep-sea mining, plastic impacts to the ocean, and the cost for the people that rely on it. By the end of this talk, you will have a broader understanding of the human impact to the ocean that may result in you being a little salty. Brace yourself, because unlike the Titanic, we can see these problems coming. First, we will cover the most recent radiation disaster, with this image of the radiation spill projection from the Fukushima reactor meltdown in 2011. It is still showing the span of cesium-137, which has a half-life of 30 years through international waters, as far as South America. This is a substantial distance. This spill has even led to the mutation of creatures living in this environment. The triangles that you are seeing are the sample locations, with the darker colours representing higher concentrations of the radioactive material. As you can see, Australia's east coast is experiencing low levels of this isotope, but in a region that is filled with substantial marine life, more commonly known as the Great Barrier Reef. What this chart, however, does not show is the seepage into the surrounding areas or how deep it penetrates. While we are discussing waste, did you know that desalination plants that produce drinking water out of seawater use reverse osmosis and pump the concentrate back out to sea, which results in a hostile environment? This is due to the supersaturated element-rich concentrate that takes some time to dilute back into the ocean. How does this relate to Perth? We currently source almost half our drinking water from the ocean. As with the arid environment, the city would not be able to sustain the population with dam water alone. This may impact your next choice of sparkling or still water when eating out. Perhaps those water restrictions in summer don't sound like such a bad idea anymore. We are digging a little deeper on this one, as Van Dover and their colleagues found that deep-sea mining has both short and long-term effects, given that accessing the material in the first place is destructive and causes the exposure of byproducts into the surrounding area. With the hostile environment, remote machines may have to do the work. This is without the direct management that surface mining has, which may lead to spill issues arising. The image displayed shows that noise pollution from underwater activities is listed as a potential hazard, with the associated risk being that many marine animals are susceptible to noise as they use it to communicate. This may result in fauna versus machinery engagement. One study, led by Simon Ladle, found that even after 26 years of an underwater mining simulation, that the area still had not returned to habitation levels of before the experiment, and have speculated that larger scale mining could result in complete destruction of the marine habitat. This experiment used two different areas and used a furrowing light technique to disturb the area to the size of 1,100 hectares. To give you an idea of the scale, that area is a little over 900 football fields. The images come directly from the research material, with the left side showing the location of this experiment, and the images to the right display the methods used in the simulation. According to Moore from the Encyclopaedia Britannica, the world has some big issues, as 2/5 of the world's oceans are covered in plastic, with one island of the plastic measuring 1.6 million kilometres and massing as much as 79,000 tonnes. The major concern with plastic is that it takes many years to break down, and during this time it impacts heavily on the marine flora and fauna, with half of all seabirds either ingesting or getting trapped in plastic waste. The image shows both Pacific patches, with a convergent zone being made up of fresh waste, yet to find a garbage patch. Another study found that it takes just under a year for plastic waste from Japan to wash up on US beaches, and that was only in relation to objects large enough for the wind to push them along. Smaller items would make their way to one of the garbage patches, as seen in the imagery. The Breton and their staff found that microplastic makes up 95% of all plastic waste. Microplastic gets its name from the particle size being under 10 millimeters, and this is due to both the degradation of larger pieces of plastic, as well as material that ends up washing from our roads or rubbish centres into the waterways and then into the sea. As you can see from the image, the particles are quite small and very inedible. Given that as of the year 2014, it was estimated that 270,000 tonnes of plastic were either dumped or washed out to sea. This means that almost 260,000 tonnes of this waste will end up as microplastic eventually. Our current capacity of measuring plastic smaller than 5 millimeters sits inside a laboratory environment, and as such, the amount of plastic in the ocean could be much higher than previously thought. Items that fit into this category are tyre dust from roads or paint dust from building operations. It is estimated that the cost of plastic cleanup ranges from $370,000 to $3.7 million for the tonnage given in the year 2014. Some considerations for this price range are the removal of plastic by mechanical means, as well as economical damage to the marine life and the industries that rely on the ocean to survive. The graph displayed shows the impacts to oceanic life and how different species engage with both buoyant and subsurface plastic. And while both algae and bacteria are living the high life, it comes at a cost. Due to the drifting nature of plastic, it allows these organisms access to previously barred areas, which result in the destruction from disease or aggressive species in the new environment. Given that it is well known that plastic is able to be recycled, perhaps more emphasis should be placed on reusing this resource. During this talk, you have learned about the human impact to the ocean, and by means of spills ranging from sewage to radiation, our involvement in the destruction of habitats from mining activities, and the quantity of plastic in the ocean. It is up to everyone to make an impact in their own households, use of plastic products, and perhaps this discussion will enable future generations to aspire to change on all the points mentioned. Education and constructive change is the best defense against negligent ocean pollution, as the change starts with you. In closing, I do hope that you have found this presentation engaging, and that you will extend your forgiveness to me next time you're drinking a glass of water, and also that I extend my apologies to you, the viewer, for potentially ruining mussels and other filter-feeding types of animals that may make up your diet.